Hey, what's up, Math 8? This is Mr. Bainey once again, and we're going to get started on Module 8, 8.1, solving systems of linear equations by graphing. So let's start with some vocab since this is the first lesson. A system of equations is when we have two equations, both linear equations, and those equations are going to generally have an x and a y. It could be two different variables, but let's just say two equations and there's two variables. Again, usually x and y. A solution to a system of equations is when both equations have the same solution, the same answer. Okay, so remember that when we graph a line has an infinite amount of points. If we graph two lines, each of those two lines has an infinite amount of points. But if they intersect, there is one point where it's on both lines at the same time. So another way to describe our solution to a system of equations is where the two lines intersect. And they will intersect at a point. So we'll see what that looks like in a moment. Remember that the slope is our unit rate or our constant rate of change, and that is our m. Okay, I'll show you the y equals mx plus b here in a moment. The y-intercept is where the line crosses the y-axis. That's our b in our y equals mx plus b. So I'm going to write it down here next to our first example, y equals mx plus b. This is review, and this was also our essential skill in quarter 2. So we had a chance to get a lot of practice on this, and you will keep practicing it. If you feel like you understand this pretty well, you should do well in this lesson. Okay, so we have two equations here. We have y equals 3x minus 2 and y equals negative 2x plus 3. So our first step is that we're going to graph the equations. This is a system because you see there's two equations, and we have our x and we have our y, so it's two variables. So y equals 3x minus 2. You see that we have our m is 3 in the first equation, and our b is negative 2. Okay, so remember that our b, our y-intercept, that is where we start. Negative 2, so if I go down 2 on our, from our origin, right, that's our b, our y-intercept. And then the 3, if m equals 3, that's 3 over 1, okay? And remember that the slope, I'm going to write it down up here. Go ahead and make these notes, especially if you aren't too comfortable with this yet. Okay, rise over run, which is a fraction, right? Rise is on top, run is on the bottom. And that means that our slope of 3 over 1, right? It was 3, but I changed it to a fraction. We're going to rise 3 and run 1. So from the graph, from my y-intercept of negative 2, I'm going to rise 3, run 1. So I end up right here, okay? Those 2 points could make our line, but we're doing a system and it's where they intersect. We want our line to be really, really accurate. So I'm going to keep going just because it's, it's Just going to make our line straighter. It's going to make it more accurate. It's going to make it easier for us to see the solution. So I'm going to go up 3 and right 1 again. I could also go down 3 and left 1 from my first point because that gives us the same line. And there you have it. There's 4 points that make my line, and I can make it pretty accurate now. My second equation has an m, or a slope of -2, and a y-intercept of +3. So we start at +3. That's our y-intercept. That's right here in blue. And our slope of -2, I just put -2 over 1. And that means I'm going down 2. From here, I'm going down 2, and I'm going right 1. Down 2, right 1. From this point, down 2, right 1, down 2, right 1, down 2, right 1 again. I can also go up 2, left 1 from my first point, and I get the one all up at the top, and here is the line. Okay, tons of points on that one, but remember, it consists of an infinite amount of points in between those. So our solution, it looks like, is that point that we have where they intersect. It's this point right here. It is the point 1, 1. That's our answer. Now the next question asks us, is the point 2, -1 a solution to each equation? And we can see on here that 2, -1 is the point down here, right? It's right here. Is that a solution to each equation? Meaning, is it a solution to our system of equations? Now we can observe here that it isn't, but let's just see what it looks like when we actually put it into our equations. Okay, so I'm going to work these down here. For 2, -1, that means our first letter is our x. So 2 is x. -1 is our y. So y equals 3x minus 2. Y is -1, remember, equals 3 times 2, and then minus 2. So then we just work this out. 3 times 2 is 6, and then 6 minus 2 will be 4. So that's a false statement. That means that this up here, 2, -1, not a solution. Okay? And remember, that was the first equation. That's the equation that I graphed in red. Now y equals -2x plus 3, the one that I graphed in blue. Over here on the right side, let's check our work mathematically, or arithmetically. Y is -1 equals -2 times our x. X is 2. Plus 3. So -1 equals, let's see, -2 times 2 is -4. And -4 plus 3 is -1. So this is true, which tells us that this point is a solution. That should make sense because the point 2, -1 is on the blue line. You see it right there, this one. It's on the blue line, but it's not on the red line. So we get a true statement. It's a solution for the blue line, but it doesn't work for the red line. And when we solve a system, like if we use 1, 1, right? This is our answer. It's on the blue line and it's on the red line. So that's our answer. Now, we're going to look at an equation that's a system that's a little more difficult but you may come across at some point. You won't see it in today's assignment or anything. But if we have equations that don't look like y equals mx plus b, so if it doesn't look like this, if it's not y equals slope x plus y-intercept, then we need to put it in that form. So we're going to quote unquote fix these equations here so that it looks like y equals mx plus b. And you see here we have x plus y equals 8. And from last module, we learned how to add, subtract, multiply, and divide things on both sides so that we can get the variable by itself. And that's what we're going to do. We're going to get y by itself. So we have y equals mx plus b. What we're going to do is we're going to subtract x. And over here, subtract x. And you can even draw your little fence if you want to. If I subtract x, this is now gone over here. X minus x, this is 0. So here, I'm just going to circle that. And we have y equals, this is a positive 8, by the way. So see how I write this. I can't combine them. They're not like terms. So this is just negative x plus 8. And then on the second equation, I'm going to subtract 2x. Subtract 2x. That's a 0. And I'm left with y. Then I have negative 2x plus 11. So that's a positive 11. Now we're going to solve this by graphing. And now I'm going to go through this pretty quickly, just because the whole intention of showing you this was to show you how we get y equals mx plus b if it doesn't look like it. So the y equals negative x plus 8. We start at positive 8. Negative x means negative 1x. And that means my slope is I'm going to go down 1, right 1. Down 1, right 1. And I can get a ton of points doing this. So here's my line. I can also go up 1, left 1. Okay. And then the second equation, I start at positive 11. So 8, 9, 10, 11 is way, way up at the very, very top. Negative 2 for my slope means I'm going to go down 2 and right 1. Down 2. You know what? Let me use a different color here. Down 2, right 1, and down 2, right 1. Look, I already see where they intersect. So it's when you graph a point that's where another point's already there. So I'm not going to keep going since I already see my answer. There's my second line, and this point right here, what point is that? 3, 2, 3, 4, 5. 3, comma 5. The question on the left says, where do the lines intersect? They intersect at the point 3, comma 5. So that's our solution. Remember, it's a solution to the system because it's on both lines. Let's look at some other examples, and even ones that I'm going to have you try. On the back of your notes, you're going to see 4 blank graphs. They're not going to have any equations written there. So I want you to write these. On the top left, go and label it number 1. Write these 2 equations, and let's go ahead and graph them. The first equation, the slope is like a negative 1, right? Negative x is the same as negative 1x. Y-intercept is a positive 4. So I start at positive 4. Okay. Let me just remind you all, just so you understand how I'm getting these. y equals mx plus b, where m is the slope, b is the y-intercept. Okay, I start at positive 4. The slope is -1. To change it to a fraction, put a 1 underneath. And that means I'm going to go down 1, since it's negative, and right 1. So down 1, right 1. Keep doing it to get more points. Down 1, right 1, down 1, right 1. Or to go backwards from our first point, up 1, left 1. Okay? The next equation, y equals 3x. I can see that my slope is 3, but look to the right of the 3x. We don't have anything there. So that's the same as adding 0. Adding 0 doesn't do anything. That means our y-intercept is 0. So I'm going to start at 0, right? That makes this thing proportional. And a slope of 3 means 3 over 1. So we're going up 3. That's our rise. Right 1. That's our run. Or they're both positive. So up 3, right 1. Look at that. I'm already at my solution. So I'm not going to graph any more points. I see where they intersect. Here's my line. And our answer here is 1, 3. Okay, so there's not really any new concepts from last term when we graph the lines, right? We use slope and y-intercept. We talk about this a lot. The only new thing is that we're doing two lines on the same graph, and then seeing where they intersect. Okay, but the actual skill of graphing is something we practice quite a bit. Number 2, I want you to actually try this one out. As you're writing these equations, you can put a 1 in front of this x right here, since there's no number there. X is the same as 1x. Go ahead and pause the video so that you can try this, graph the 2 lines, see where they intersect. And then after about 3 to 5 minutes, you can unpause it and I'll go through it and you can compare. Okay, our first equation, slope is 3, y-intercept is -4. Start at -4. I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, and so on. For my first point, I could also go down 3, left 1. Here's my line. Oh, I messed up there. Down 3, left 1. Okay. Yeah, one of the common mistakes, especially if you know how to graph, is the miscounting. Looks like that's what I did there. On the second one, our slope is 1, which is the same as 1 over 1. Y-intercept is +2. So start at 2, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, and I see my answer. Let's connect this, make our line. Here's where they intersect, and that is 3, 5. That's our answer. Let's look at number 3. Go to write down these equations for number 3. And I made a slight mistake here. This should be y equals negative x minus 4. Okay, that's going to make a difference in our solution and how the line looks. So we know that a negative x is the same as negative 1x. So negative 1 is our slope as a fraction, -1 over 1. And y-intercept is -4. Okay, so here is my y-intercept on the graph, -4. And I'm going to go down 1, right 1 from that point. Down 1, right 1, down 1, right 1, and so on. I could also go up 1, left 1. If I'm going backwards. And I suggest going to the edge of the graph just so you have all the points you need. And you can make this really, really accurate. So much easier to get your solutions. On the second equation, we have 1/2 x is our slope. And this is interesting because 1/2 is already a fraction. So the rise is 1 and the run is 2. Y-intercept is +8. So I'm going to start at +8. I'm going to go up 1, right 2. And I'm already at the edge if I go up 1, right 2. So I'm going to go down 1, left 2. Down 1, left 2. And this is exactly why you want to go backwards and try to make your line accurate, is because my solution's way back here. And there we have it. Okay, that's our solution. What point is that? -8, 4 is our solution. Number 4. We'd like you to try this one. So go ahead and pause it, and then I will quickly go over it so that you can compare. Here our slope is -2. Y-intercept is 5. Let's graph that at 5. The slope -2 means I'm going to go down 2 and right 1. So again, just keep going. You see, I'm doing all these pretty much the same way. I start with the y-intercept. That's my first point. Then I use a slope to get as many other points as possible. Then I draw my line. Then I do the exact same thing for the other one. I start with my y-intercept. I use my slope to get as many points as possible to make that line. On the next one, the slope is 1/2, just like the previous problem. Y-intercept is nothing, +0. So I start at 0. I go up 1, right 2. And there, just on the second point, I got my solution because it's on the other line. But I'm going to have some more points here just to make it nice and straight. Sorry, that's a horrible line. That's a little better. And our solution right there is 2, 1. Okay, and this is all we're practicing today. Now, what you're going to see in the future lessons for this module is we're going to still look at systems of equations. So our 2 equations, 2 variables, but we're not going to graph them anymore. This is one method of solving them. We're going to look at other methods in the future. Okay, thank you for watching. I hope this was helpful. You have some problems to practice for your assignment. Give it a try, and make sure you come back with questions to ask me. Okay, thank you. Have a good day.